Question 7.42 says predict the major product of each of the following reactions. So in question A, we have a tertiary alcohol. So a tertiary alcohol. And we're treating that with HBr, which is a strong acid. And when we treat a tertiary alcohol with HBr, what happens is that we can get a substitution via an SN1 mechanism. So just to give you a little bit more information, if we draw the mechanism, the first step is going to be protonation on the oxygen to convert our hydroxyl into an oxonium, which converts it into a good leaving group, because then it will leave us water, which is the conjugate base of hydronium, which is a strong acid. So let's draw this intermediate. Here we go. And then we're going to get the loss of our leaving group like that. And then we're going to have our tertiary carbocation like that. And obviously in this step we lost water. And then our bromide can come in and attack our carbocation like that. And there we go. And that's going to be our product. It's not a stereocenter. There we go. So we get substitution when we treat a tertiary alcohol with HBr, a strong acid. If we take the same tertiary alcohol and we treat it with sulfuric acid, which is also a strong acid, what happens when you treat a tertiary alcohol with sulfuric acid is you get elimination. In this case, since it's a tertiary alcohol, it's going to proceed via an E1 mechanism. So if you remember, when we have a solution of sulfuric acid, what we're actually going to have mostly present in the solution will be hydronium, because sulfuric acid is an aqueous solution. So here we go. And if you remember the leveling effect, mostly what's going to be present again in the solution will be hydronium. So the first step is going to be protonation of the alcohol, again to convert it into a good leaving group. So here we have our good leaving group, which is very similar to the first step, except we're using a different acid. Then we have the loss of our leaving group. So I'm using water to form our carbocation, but in this case, we're going to regenerate our hydronium via an elimination mechanism. And when we treat a tertiary alcohol with sulfuric acid, the major product is going to be the Zaitsev product. In fact, it's going to be the only product, will be the most substituted alcohol. So if I draw in the most acidic proton here, what's going to happen is that water can remove that proton like this. There we go. And give us our final product, which is the most substituted alkene. So that's dehydration using concentrated sulfuric acid in question B.